How to master Claude-assisted debugging for ML systems. In this video, you'll learn how to leverage Claude to optimize debugging processes in distributed ML environments, enhancing performance and reducing downtime.
Did you know that over 50% of time spent in machine learning projects is dedicated to debugging and optimizing code? Welcome to our channel, where today we dive into how Claude can revolutionize your debugging process. In this video, you'll discover how to set up Claude for distributed ML systems, tackle common debugging challenges, and utilize real-time error detection. Stick with us to learn best practices and hear about successful case studies. Don't forget to subscribe if you want to become a master in AI-assisted debugging. Claude is a cutting-edge AI tool designed to assist developers in debugging complex machine learning systems. Unlike traditional debugging tools, Claude uses advanced machine learning algorithms to understand code patterns and detect anomalies in real time. One of its standout features is its ability to adapt and learn from each debugging session, making future problem solving more efficient. In distributed systems, where multiple nodes and processes are involved, Claude excels by providing a cohesive view of system performance and pinpointing errors with precision. This capability not only saves time but also significantly reduces system downtime, enhancing overall productivity.
Setting up Claude in a distributed ML system is a straightforward process, but it requires attention to detail to ensure optimal functionality. First, install Claude using the official package manager compatible with your environment. Once installed, configure Claude to interface with your distributed network by specifying the nodes and processes you wish to monitor. Integration with popular ML frameworks like TensorFlow or PyTorch is seamless, thanks to Claude's comprehensive APIs. Test the setup by running sample datasets to ensure Claude is accurately detecting and logging data flows. If any issues arise, Claude's documentation offers troubleshooting tips to help resolve common setup challenges.
Debugging in machine learning systems poses unique challenges, from identifying data inconsistencies to resolving algorithm inefficiencies. In distributed systems, these challenges multiply as data is processed across various nodes, making error tracking more complex. Traditional debugging methods often struggle to provide a holistic view, leading to increased time in isolating issues. Common problems include synchronization errors, data drift, and resource bottlenecks. Claude addresses these by offering an integrated platform that not only identifies but also anticipates potential issues, utilizing its AI-driven insights to streamline debugging and optimize performance. One of Claude's most powerful features is its real-time error detection. By continuously monitoring your ML system, Claude can detect anomalies as they happen, providing instant alerts that enable rapid response. This proactive approach minimizes downtime and prevents minor issues from escalating into significant problems. To activate real-time detection, access Claude's dashboard and configure the alert settings according to your system's needs. Set thresholds for error types that are critical to your operations. With real-time data visualization, you can observe how your system responds to various loads and conditions, allowing for timely adjustments and optimizations.
Claude is designed to work effortlessly with major ML frameworks like TensorFlow, PyTorch, and scikit-learn. This compatibility ensures that you can integrate Claude into your existing systems without overhauling your infrastructure. Claude's extensive APIs provide the tools needed to link its functionalities with your framework, offering a seamless experience. This integration allows for continuous monitoring and debugging across your ML pipeline, enabling you to leverage Claude's insights without interrupting workflow. In practice, companies have reported increased efficiency and reduced debugging times, demonstrating the tangible benefits of integrating Claude into their systems.
To maximize Claude's potential, following best practices in debugging is essential. Start by regularly updating Claude's settings to align with your system's evolving needs. Utilize collaborative debugging techniques by sharing findings with team members through Claude's reporting tools. This not only fosters a team-based approach to problem solving but also accelerates the debugging process. Continuously monitor performance improvements post-debugging to ensure that optimizations are effective. Additionally, take advantage of Claude's learning algorithms by analyzing past debugging sessions to predict and prevent future issues. These strategies ensure that your ML systems run smoothly and efficiently.
Real-world case studies highlight the transformative potential of Claude in ML debugging. Take for instance a tech startup facing frequent system crashes due to data overloads. By implementing Claude, they identified critical bottlenecks and optimized data flow, reducing downtime by 40%. Another example is a financial firm that used Claude to enhance fraud detection algorithms, resulting in a 30% increase in detection accuracy. These stories underscore how Claude's AI-driven insights can lead to significant operational improvements, providing companies with a competitive edge. The lessons learned from these studies emphasize the importance of integrating advanced tools like Claude for sustainable growth. The future of AI assisted debugging is poised for exciting developments as technology continues to evolve. Emerging technologies like quantum computing and edge AI are set to redefine how we approach debugging. AI's role in software development will expand, offering even more sophisticated solutions for detecting and resolving errors. Claude is expected to incorporate these advancements, further enhancing its capabilities. As AI becomes integral to industry standards, it's crucial for businesses to stay ahead by adopting these innovations. Preparing for future challenges will involve continuous learning and adaptation, ensuring your systems remain robust and efficient.
As we conclude, remember that mastering Claude can significantly enhance your machine learning system's performance. Efficient debugging not only saves time and resources but also leads to superior outcomes. We encourage you to continue exploring Claude's capabilities and share your experiences in the comments below. Your insights could be invaluable to others in the community. Don't forget to subscribe to our channel for more expert tips and tutorials. Together, let's push the boundaries of what's possible with AI-assisted debugging.